So, welcome to the class. Now, we are going to discuss about the grinding or the cutting fluids, which I have discussed in the previous class, that the grinding fluids and cutting fluids both are same. If you are using the cutting fluids in a grinding application, normally it is called as a grinding fluid. If you are using the cutting fluid in a machining operation like a lathe milling, it is called machining fluid or cutting fluid. Okay. What we are going to see in this particular class is the grinding fluid emissions basically and sustainable grinding process. In the previous class, we also saw the glimpse of negative effects, how it is going to affect the operator, how it is going to affect the soil, how it is going to affect the water bodies and many more. So, elaboratively we will see in this particular class and what is a solution for it. Okay. If there is a problem, we are here as an engineer to show some solution for it. Okay. In this particular class, we will see what are the emissions that takes place that comes out from the machining or the grinding zone and how to overcome these type of problems. So, overview of this lecture, overview of grinding cutting fluid emissions, what are the emissions and possible consequences. Some of the important chemicals or the emissions that is chlorinated paraffins and its adverse effects. The other one is polyaromatic hydrocarbons and what are these adverse effects. The third one is nitrosamines and nitrites and what are these adverse effects, the other emissions and its consequences on system as well as surroundings. We will also see an MQL based sustainable grinding, how the droplets are generated, what is the contact area, how this mist is going to take out by forcibly the temperature in the grinding region, that is called forced convection. What mean by free convection and other things. What is the mist droplet effect on the cutting forces as well as temperature in the grinding process, that all we will see in this particular class. The cutting fluid emissions, the overview of cutting fluid emissions, if you see, as I said, the first and foremost one is chlorinated paraffins. This is the one of the highest emission that is taking place in the machining arena or the grinding arena. Second one is polyaromatic hydrocarbons and nitrosamines, nitrites, endotoxins, sulfur, lead, boron, zinc containing substances, cobalt exposures. Normally cobalt exposures are confined to the metal cutting where tungsten carbide based tools are used. If the similar things are normally tool and cutter grinders, whenever you use the grinding process for cutting or giving some angles to the tungsten carbide cutting tools, this will come and other contaminants. Okay. So, what are the consequences? If you see, the consequences are the diseases that it causes. Chlorinated paraffins causes folliculitis, dermatitis. Polyaromatic hydrocarbons and nitrosamines causes cancer, nitrites will cause skin cancer, endotoxins causes respiratory irritation and asthma, which is one of the highest in terms of workforce, and the sulfur, lead, boron, zinc containing substances causes hypersensitivity and pneumatics. Cobalt exposure normally leads to the bronchitis and other contaminants which we will see will causes keratosis and oil acne. These are the diseases or the consequences that are because of these emissions. These are the emissions. These are the possible diseases. Okay. Consequences are possible diseases. Okay. The first one, chlorinated paraffin. The chlorinated paraffin, first you should understand what is a chlorinated paraffin, then we will go ahead with what are its consequences. Okay. In that circumstances, These chlorinated paraffins fall in the category of organic chlorine containing substances. Normally, people, you might have studied in your intermediate or 10th class or in the early stages of your bachelor's, alkanes, alkenes and alkynes, carbon and its compounds, where alkanes refers to CnH2n plus 2, alkenes represent to CnH2n and alkynes represent to CnH2n minus 2. In this category, alkanes CnH2n plus 2, where Cn, assume that CnH2n plus 2, okay. So, it will be like C2H6, okay. Instead of this, what will happen? C2H5, one hydrogen is replaced by chlorine. These are nothing but the organic chlorine containing substances, okay. So, these are the alkanes type of things where one of the hydrogen is replaced by the chlorine. The present in straight oils and synthetic oils. Straight oil means you have a big chain where the branches are very less, and in these type of things, additives main function is to reduce the cutting fluid viscosity. Normally, if the cutting fluid viscosity is less, what will happen? If a grinding wheel is there, assume that the grinding wheel is rotating and I have a microns gap. Assume that the depth of cut is given is 2 microns or 5 microns. Depth of cut is very, very less. If my cutting fluid is like honey, it cannot penetrate. If my cutting fluid is like water, it can penetrate. Because, why? Because the cutting fluid is low viscous in terms of water, but in terms of honey, it is not low viscous. That is why you need to use certain additives where the viscosity of your cutting fluid will goes down. That means that it can freely flow by the virtue of capillary action or some other action. That is why this, whenever you add some additives to reduce the viscosity of cutting fluid, this will emit the chlorinated paraffins. The classified according to the length of their carbon chain. Basically, these chlorinated paraffins ranges from C10 to C30, okay, and the amount of chlorination is 35% to 75% by weight. These are three types basically. One is a short chain, another one is intermittent chain and long chain. Simply you can see there, if it is the chain or the carbon chain is between 10 to 30, it calls as a short chain, 14 to 17 it is intermediate, and above 17, that is 18 to 30, normally these are all long chain paraffins. This is about the chlorinated paraffin as such. How it is come into picture? Whenever you add a low viscous additive, or if at all I want to make a cutting fluid low viscous, you have to add some additive. This additive indirectly enhances the mechanical performance from the point of tribological action, that is the positive factor. From the negative factor, what is it's going to do is, it is going to give the emissions like chlorinated paraffins. Okay. These chlorinated paraffins, how these are going to affect the human or the operator? The first effect is dermatitis. This is called contact dermatitis. Whenever the grinding process is going on, what will happen? This cutting fluid, or when the cutting fluid falls on the grinding region where the workpiece and grinding wheel is contacting, temperature is very high, thermal cracking will takes place. At the same time, this fluid will flash because of the grinding action onto the operator. Okay. In that circumstances, the dermatitis will come. Straight and solubilized based cutting fluids causes the dermatitis, and this also happen due to water logging after prolonged immersion. Normally, your cutting fluids, whenever you use 1 liter of cutting fluid with respect to 10 liters of water. So, you have water in it in a major amount. In that circumstances, if you are keeping this particular, normally if you see some of the laboratories, what the people will do is just the cutting fluid tank will be filled. This week they have experiment, next week they have experiment, so on, because it is not regularly operating. In that circumstances, what will happen, semester they may operate 10 times, the next semester. So, it is staying for a prolonged time, which causes this problem. Okay. The main cause behind contact dermatitis is irritating substance, which is called allergen. Normally, you people will get, oh, that person got allergy, this person got allergy. What will happen whenever you have allergy? You will get pain, at the same time you will get other things also. The changes on your skin will take place that attacks the horny layer of the skin. You can see the horny layer of the skin in the 3 pictures. The irritating substance contact dermatitis accounts for 80% of all the cases in the contact dermatitis and is also painful. The inflammation affected tissue present is epidermis, which is nothing but the skin outermost layer, and outer dermis, the layer beneath the epidermis. Now, we will come into the pictures that are say. The first one is cumulative toxic contact dermatitis. It is comes as a contact dermatitis. What will happen? This chlorinated paraffins, whenever it falls, what will happen? It causes allergy. Okay, that is called acute toxic contact dermatitis, allergic contact dermatitis. The most of the dermatitis in this particular chlorinated paraffins is contact dermatitis. Okay. What will happen? Whenever it falls on the surface, it causes allergy and it causes the epidermis, that is nothing but the outer layer. This is the outer layer. This outer layer causes the allergy and it also causes some allergy to the layer beneath the epidermis, that is called outer dermis. That means, assume that your skin has 6 layers of different layers. The outside layer is epidermis. This will also affect. At the same time, second layer from the top is outer dermis, that will also affect. That is why this is called as contact dermatitis, because directly the chlorinated paraffins comes and contact to the surface of your skin. The adverse effects follows like this. The chlorinated paraffins also causes other adverse effects during the reduction of cutting fluid viscosity, but also causes irritation by defatting action. So, defatting action means what will happen? Dehydration is a common word. People will, oh, this is summer, people are going out and you will get dehydrated. That means that water is going off. Defatting. The defatting action means it is breaking the fat. Whenever the cutting fluid falls in a high temperature region because of the temperature or because of the other things, what will happen? It breaks the bonding. So, that is how the fats, there are unsaturated hydrocarbons, double bond, triple bond, these are unsaturated one. These are ready to break. If there is some external energy, it will try to break. In that circumstances, the defatting will take place. Highly toxic skin contact may be. So, these are chlorinated paraffins are highly toxic to the skin, which may causes the chlorine act and folliculitis. Okay. What do you mean by chlorine act? The picture you can see here, this lady on the face, it is chlorine act. The picture is not taken from the cutting fluid emissions, but to explain you what is chlorine act, we have taken this. This is also an adverse effect from the point of swimming pools also. If the chlorine is not maintained properly, in that circumstances, chlorine acne will come. Okay. The folliculitis is nothing but if the cutting fluid falls on the face or the hair of a operator, this cutting fluid by the virtue of gravity may enter into the pores and it will cause the folliculitis. Wherever it goes, there the hair won't grow. That is improper growth of the hair on a human body is called folliculitis. Might also be the carcinogenic, that is lifetime exposure of short chain chlorinated paraffins to animals or the humans causes thyroid and liver cancers. These are the thyroid and liver cancers will also come into the picture if small chain chlorinated paraffins are exposed for a long time. Normally an operator operates in his government life or in a life, assume that a operator got a job at the age of 23 or 24 and he is going to retire in the age of 60 or 65. That means that he is going to operate more than 30 years, which is a huge time. If he is not going to take the proper precautions, he may be experiences to the long time these emissions, which may causes lot of problems. So as an engineer, you have your responsibility to explain your staff that this is the right procedure. Wear the apron, wear the gloves, wear the mask, and you should protect your staff. It is not that a staff dies or something whenever because of these emissions. It is the family that comes on road. So you should be very careful about your staff's health and other things. The main motto of mine to explain you is this should be taken utmost care. Okay. So as an engineer, it is our primary responsibility not only give the profit to the company, at the same time it is our responsibility to take care about our staff. So the adverse effect folliculitis, chlorinated paraffins, as I explained you, the folliculitis is nothing but the inflammation of one or more hair follicles. Whenever the operator is standing in front of the experiment, if there is a splashing of the cutting fluid or the grinding fluid because of the high speed of grinding wheel, what will happen? It may fall on its skin, it may fall on his hair and other things. What will happen? Wherever it falls, assume that the operator is like this, it fall on his head. After some time he will stand like this because of the by virtue of the gravity, it goes to the pores, and wherever the pores are occupied by this cutting fluid, their hair won't come. You can see here on the hair, some places hair is there, some places hair is not there. This is called as folliculitis. So wherever the cutting fluid fall and occupied the holes or the pores of the skin or head skin, their hair won't grow. This involves blocking of the pores of the skin by oil particles. So this blocks the pores of the skin so that hair won't grow. This in turn causes improper growth or irregular locational growth of hair, that is called as folliculitis. Apart from palms of the hands, at the same time soles of the feet, it may affect most of the skin, even though it may occur on your hands also, so that the hair won't grow at that locations. The second important emission is polycyclic aromatic hydrocarbons. The commonly present in the mineral oil based, this is a lubricating. That means that it is a major component in the cutting fluid itself. Okay. These are lipophilic, that means that they are mixed easily with oil rather than water. Some of the PAH, that is polycyclic aromatic hydrocarbons, are benzopyrene. You can, whatever the structure that you are seeing here is a benzopyrene. This is one of the common example of PAH. Whenever I use PAH, this stands for polycyclic aromatic hydrocarbons. So whatever you have seen the benzene rings in the previous one, what will happen here is when the benzene ring fused to the pyrene due to incomplete combustion at temperatures below 300 to 600, the benzopyrene is formed. What will happen is pyrene and benzene, these are fused together. You might, okay, when this fuses, whenever there is a improper combustion. If you see from the IC engine's point of view, you also see that improper combustion leads to lot of smoke and other things. Why? The same thing will happen in the metal cutting also, because whenever you are going to do the metal cutting or the grinding, the temperatures that you are going to expect is not that much high. At the same time, the cutting fluid cannot penetrate into the deeper zones or the seizure zones of your cutting also. In that circumstances, what will happen is the temperature is much low from the contact region, away from the contact region. In that circumstances, the basic problem is improper combustion. If this improper combustion is taking place in the grinding operation, and when the benzene ring and the pyrene is fused together, forms benzopyrene. This can enter through the breathing in the contaminated air. What will happen once the benzopyrene is formed, because of the temperature that is in the grinding zone, it will evaporate. This evaporation contains benzopyrene ring. This may directly go to the, by falling on a skin, it will directly go through the skin. At the same time, it can also go through the respiratory system. Whenever it enters through the skin or through the breathing, what will happen? Benzopyrene is dangerous if the percentage is less than 0.1 to 0.005% and highly dangerous if the percentage is 0.1. Okay. So, this results in diol epoxide that reacts, the body attempts to metabolize benzopyrene and then binds to DNA, which results in mutations and eventually cancer. That means, whenever this benzopyrene enters into the body, what will happen? It will go and occupy the DNA. DNA is the most important part of your cells. Okay. So, if it covers that particular DNA of that particular cell, the controlling of the growth of that particular cell, which is originally controlled by the DNA, now it loses its capacity and releases or grows uncontrollable cells. That is nothing but by action of mutations, and eventually you can call it as a cancer. I hope you might have understood this one. Okay. So, what I mean to say is, the resulting diol epoxide, when the body attempts to metabolize the benzopyrene, what will happen? This chemical will go and binds the DNA of a cell. Assume that you have a cell, DNA is at the center, it will goes and occupies the DNA. DNA is a person, DNA is a thing which is most important to control the cell growth. If this particular benzopyrene goes and occupies that position, what will happen? Now cell do not have a control of the DNA. Now the benzopyrene will decide the cell growth. If benzopyrene decide the cell growth, how many it want? It can grow. So that uncontrollable growth of cells is nothing but the cancer. It can cause the damage to a person's lungs, liver, skin, kidneys through the exposure. If it is exposure through the breathing, causes the lungs cancer, liver cancer. If it is exposure to the skin, it may causes the skin cancer, and if it can enter into the kidney, it may damage the kidneys also, because it is a chemical. Once it enters into the body, it may go to the locations through the blood. The contact with PAH may causes the readiness, blisterings and peeling. Normally, these are also another effects which causes readiness, that means it will become red, blisterings and other things. Peeling of the skin also will causes. Polyaromatic hydrocarbons, whatever you have seen in the previous one, that the same thing is explained here in a schematic way, that is benzopyrene, whenever it will enter into the body, what will happen? You have oxygen and water. Your body, if you see the advertisements of AquaGuard or something, AquaGuard, Kent, other water purifying systems, they will say that your 73% of your body is water. That means that you have abundant oxygen, you have abundant water. Whenever benzopyrene will react with oxygen and releases water and forms benzopyrene 7,8 epoxide, whenever it reacts with the water content in your body, what will happen? Benzopyrene 7,8 diol, and whenever again it will react with the oxygen that is available inside the body, it will form a benzopyrene 7,8 dihydrodiol 9,8 epoxide. This is the thing that causes the cancer. Okay. What it is doing is, it is doing the metabolism inside by reacting the water, by reacting with the oxygen, and it binds to the DNA and takes the control of the cell growth into the hands of this benzopyrene, which is converted into benzopyrene 7,8 dihydrodiol 9,10 epoxide. Then it will, enormous growth of cells will takes place and causes the cancer. The third one is nitrosamines. The nitrosamines are formed as a result of reaction between alkanolamines as well as, which are nothing but the emulsifiers, and surfactants and nitrites, which are corrosion inhibitors. So, from the positive point of view, you required corrosion inhibitors or rust inhibitors, which we have seen in the previous class. At the same time, emulsifiers are required to make a uniform emulsions. The cutting fluid containing more than 50 micrograms of nitrate per gram of the cutting fluid together with monoethanolamine, diethanolamine or triethanolamine were banned. Okay. The 80% of nitrosamines, including N-Nitrosamines, are potentially carcinogenic. That means that these are very dangerous from the point of causing the cancer. N-Nitrosodiethanolamine is formed when the nitrite-free coolant containing either of the two amines, that is di or triethanolamine, were exposed to the nitric oxide in the air. Diethanol nitrosamine is one of the examples of nitrosamines present in the cutting fluid. Okay. This is carcinogenic. That means that if it enters into the human body, that is operator's body, it creates the cancer. That means these are carcinogenic. That means it causes the cancer. The nitrites is the another one example of the emissions. This is used as in synthetic cutting fluids as a rust prevention, that is rust inhibitor or corrosion inhibitor. The sodium nitrite is commonly found in low mineral oil or the hydrocarbon free synthetic oils. Chemical structure of sodium nitrate is shown here in this picture. You can clearly see that, and its concentration in water miscible cutting fluids are very high, ranging from 0.05 to 0.2%, and it is very toxic and hazardous substance. And the sodium nitrate is drying effect on the human skin. Whenever it falls, because of the rotation of the grinding wheel, if the splashing occur and it falls on the skin of a hand or something, what will happen? It will make the skin dry. You might have seen in the advertisement what is the drying effect. If it is dry, but there will be a problem of cracking, bleeding and other things will come. So, nitrites, for reducing the risk of formation of nitrosamines, the specifically metalworking fluid must not contain nitrosamine generating components. This applicable to the nitrites as a corrosion inhibitors as well as to few organic nitrogen containing components are nothing but the biocides. These are all in terms of this will be there in terms of the rust inhibitors as well as biocides. Whenever you are adding this type of additives to the cutting fluid, you should choose that there should not be any nitrites generation. Okay. If you can take care that, that means that it won't releases the nitrites whenever you are applying to the machine regime. This will be taken care that the water with low nitrite content, that is less than 50 milligram per liter nitrite, is used for preparing the emulsions, as the bacterial action may be chemically decompose the nitrates into nitrites. Okay. As I said, this is carcinogenic. It causes the skin cancer mostly whenever it falls onto the skin of an operator. Endotoxins are produced by the gram negative organisms when the cutting fluids are poorly maintained. That means that, as I said, in the laboratories where if you are not using frequently the cutting fluids, what will happen is that these cutting fluids are used for a semester or a 2 semester. That means that if you are not replacing or you are not changing the cutting fluid, these gram negative organisms like bacteria, fungus, these are all things will grow. It is produced from lipopolysaccharide, a major constituent of outer cell of wall gram negative bacteria, and this causes asthma and respiratory irritation. Asthma and respiratory irritations are the common problems that you can come across in the most of the manufacturing workers in the industries. Okay. The highest percentage of cases occurred among the operators and fabricators in the laboratory people, that is approximately 32.9 people. You can see these type of respiratory problems majorly in the staff because of endotoxins. Asthma is a common chronic inflammatory disease that airways which are characterized by the variable recurring symptoms, reversible airflow, obstruction and bronchospasm. So, wheezing and chest tightness and shortness of the breath are the common symptoms of this disease. As I said, it is one of the breathing problem. Asthma and other breathing problems will occur whenever there is a emission of endotoxin in the machining region or a grinding region. If it is breathe, what will happen? Your air passages, assume that I have a cylinder, this is where if there is the diameter is going to reduce, what will happen is going to take place. This is what it is going to take place. It will narrow down and causes the wheezing action, lot of sound, short breath, you cannot breathe more. Okay. And these are the common problem, and this is the biggest problem among the fraternity of the manufacturing staff. So, as a manufacturing engineer, you should provide them the mask so that the endotoxins cannot enter, or you can reduce the possibility of endotoxins entering through the mouth or through the nose. The cobalt, as I said, cobalt in a single point cutting tool you will use as a tool, that is tungsten carbide tools, where tungsten will be there and cobalt will be there. In a tool and cutter grinder, as per the abrasive process concern, whenever you are using the grinding wheel for the tool and cutter grinder, in that circumstances, when the amines of the cutting fluid attacks the tungsten carbide workpieces where you are grinding to provide certain angles, this cobalt leaching will take place. So, you know the tungsten carbide or some other powder metallurgical route manufactured tools will have cobalt. You have a cobalt as a binder, you have a tungsten carbide or tantalum carbide. What are the things, tools, if at all you want to manufacture? You manufacture mostly by the powder metallurgy route, and if at all I want to generate some angles, you have to go for tool and cutter grinder. Whenever you do it, what will happen? If you use the cutting fluid which contains amine groups, in that circumstances the cobalt will leach. Whenever the cobalt will leach, the basic problem is mechanically it loses its performance, at the same time it will leach and causes lot of problems to the operator. Cobalt leaching reduces the life and performance of the tool. If you are making a tungsten carbide single point cutting tool, the cobalt dust creates rashes and throat and lungs, and cobalt dust may cause asthma like disease and symptoms extending from cough, shortness of the breath, decreased pulmonary function, pneumonia, nodular fibrosis. These are all the things that will causes. Cobalt also causes health problems like dermatitis and respiratory diseases. It can cause allergic reactions and impair lungs. Because of the respiratory problems, you may get lot of problems. Running the clean filter can avoid the 90% of cobalt contaminants. Okay, you have to run the filter so that these particles or the micron size particles will be filtered out, so that it won't come in the next go of the cutting fluid action. Sulfur, lead, boron and zinc, these are the other emissions. Presence of sulfates promotes the growth of sulfate and reducing bacteria that converts into the cutting fluid into rancid. Normally these are all biocides. Anaerobic bacteria that develop on the cutting fluid try to produce hydrogen sulfide gas, which results in skin irritation. Normally the sulfur and these things causes the skin irritation to the operator. The boron containing components in the form of boric acid esters or boric acid alkanolamines. Boric acid alkanolamines are presently used as a corrosion inhibitors, and this causes some problems to the operator. Lead containing components were used as anti-wear and extreme pressure additives. Basically lead is a low shear strength material you can use as a lubricant material. In that circumstances, what will happen if you use the tool wear, other things will be reduced, but it has an adverse effect. Lead naphthalates were used in the cutting fluid as additives, but their increasing concentration in the blood can cause the problems. If the lead absorption takes place, then it causes a lot of problems to the blood, and it is termed as toxic if the concentration levels exceed 5 milligrams per liter. Okay, so it causes a lot of problems to the human or the operator. Now the zinc as such, it is a good if it is within the limits in the body of a human, but zinc dithiophosphates are used in coolants as additives. They are toxic, and according to European legislation they are termed as dangerous. Okay, you should avoid zinc, lead, sulfur containing substances as additives. That is the main motto of this particular slides. The main motto of these small emissions like lead, zinc, boron, sulfur, you have to avoid these chemicals as much as possible, so that, or you should use within the required limit or specified limits by the health organizations, so that you can give a better life to the operators. This is about the system, how the system will face a problem. Okay, now system means operator and operator friends who are standing up adjacent to him. So now we move to the surroundings, how the cutting fluid emissions will create problem to the surroundings. The cutting fluid emissions to the surroundings, cutting fluid mist are aerosols comprised of liquid particles less than 20 microns. Aerosols may be suspended in the air. Normally these are low density particles and very tiny particles. So these are all will stay in the air several hours and even several days, possibly in the breathing zone. If it is breathed inside a human or operator, what will happen? It will stay there itself. So inhaled particles, what I mean to say is that whenever these particles goes out through the exhaust thing, and it will stay in the atmospheric surrounding atmosphere, and the people who are nearby, they may breathe it. Okay. Inhaled particles with the aerodynamic diameter less than 10 microns deposit in various regions of the respiratory system by the complex action of deposition mechanisms. At the same time, particles below 2.5 micron aerodynamic diameter deposit primarily in the alveolar region and most sensitive part of the lungs. Okay. So normally a person can breathe a 10 micron particles in the air. If the aerosols of cutting fluid emissions, if the particle size is 10 microns, your nose can breathe it, but it may not enter into the alveolar region. But if the particle size is 2.5 microns, it can enter into the alveolar region. Okay. This is a CT scan of the lungs, and if you see zoomed version of this one, this is how it will affect the lungs region. The mist droplets can cause the throat, pancreas, rectum and prostate cancers, as well as breathing problems and respiratory illness. As I said, 2.5 microns will enter into the alveolar region. The alveolar region is nothing but this region where it looks like a nerves and other things. This is a small opening. If your 2.5 microns will go and block these particular portions, then so you will face lot of problems with the breathing. It is an inflammation of alveolar region with the lungs, which is caused by the hypersensitivity and inhaled organic dust, which particle size is less than 2.5 microns. Microbacterium species are responsible for causing these diseases, and hypersensitivity pneumatics include variety of diseases caused by the specific allergen and inhale the thermophilic and actinomycetes. Okay. So, what I mean to say is, please provide the mask to the operator so that 2.5 microns, 10 microns below this should not enter into the lungs, and if it is entered, then it is problem. So, as an engineer, again and again I am emphasizing you should take care about your company, but from the profits point of view, at the same time you should also give importance to the operator's life also. If you see residential exposure scenario, all the companies nowadays, companies are constructing outsides of the cities. In olden days, outside cities the people have constructed the companies, now the cities are expanding. So, the company adjacent to the locality. Okay. In these circumstances, what will happen? Residential exposure scenario, if it is 9 years exposure with low concentration levels of these exposures, what will happen? This is the cancer risk, and if you are high concentrations for 9 years, what will happen? This is the risk. And 30 years exposure, normally this is a risk, and if the person is exposed or the locality is exposed higher concentrations for 30 years, you can see enormous increase of cancer risk. Okay. So, the people should be aware if you are nearby the industries emissions, what are the emissions, what are the problems, so that you should take care about your locality, or if not, you should take care about your home. Okay. Adjacent to many educational institutions, adjacent to many of the villages, adjacent to many of the cities, there are a lot of companies are there. The company people should take self responsibility. You should clean it and you emit it, there is no problem. You should take care about the surrounding people also. If you use again and again and again, white cutting fluid will become brown, then it will become black. Then what the people will do is, the first and foremost thing what they will do is, they just connect a pipeline and throw into the water bodies nearby. Okay. Many of the people survives on the fishes. Some of the countries, the main food will be fishes. So, if the cutting fluid is dumped, what will happen? The fishes or the ecological system of the river, seas will damage. At the same time, other people they will do is, just they will dig a hole on the corner of a company and they will dump into it. This causes the soil pollution. Okay. The first one is water pollution, another one is soil pollution. Okay. So, these two also not good. Before you release into the river or a water body, you treat the cutting fluid so that the ecological system should be good. Okay. So, at the same time, soil pollution also you should take care, because nearby agricultural land will be there, nearby some of the educational institutions will be there, villages will be there, you should be very careful. Okay. Before disposing of the cutting fluid into the sewage system, one should ensure the following: whether it is a water soluble or not, whether received regular biocides additions or not, because it will go, if the biocides are not there, it will generate lot of organisms like bacteria, fungus and other things. And you should also check whether the chips or fine particles, like in a grinding process, abrasive particles are embedded on it. Assume that if fishes are there or some living organisms in the river, if it eats chips, what will happen? It will cut the throat and different organs of the fish and they will die. So, you should take care, you should be given utmost priority before you release into the system. Does it contains any toxic concentrations or heavy metal ions, so that the organisms which are there in the river body or the sea should not die. Okay. So, this is about the emissions. Emissions accord equal importance compared to the performance. The people always look at the performance, but they do not look at the ecological aspects. If a operator dies, manager thinks that his son will come, he dies, his grandson will come, like that. That trend should go off. Okay. What I mean to say is, please give importance to the operator. Operator, you love the operator, and he will in turn give you a good output, so that the company will go in a positive direction.